Okay, let's try this again. I was having trouble today. There are students in the hallway that are a little chatty, so we're going to talk about similar polygons. So polygons are similar if they have the same shape, but they're different sizes. I'm trying to fix my microphone too. Polygons are similar if the corresponding angles are congruent and if the corresponding sides are proportional. And the ratio of corresponding sides is called the scale factor. And if the polygons are similar, then the perimeters are also going to be proportional. And we're going to see that. So if you need to pause it to take the notes, because this is my third time recording it, so I already copied this down. We're going to talk about scale factor here. So scale factor, order matters. So when we're trying to find the scale factor of two different polygons, what we're going to do is we're going to set one side of one triangle over the other side. So if it's ABC 2 DEF, we remember that's going to be ABC over DEF. So what we're going to do is we're just going to pick one side of that triangle. So we're going to do AB over DE. So AB is 8, DE is 12. We've reduced that to get 2/3. So the scale factor is 2/3. So if we're doing the scale factor from DEF to ABC, that means DEF is going to be on the top, AB is going to be on the bottom. So DE over AB, so we get 12 over 8, which is 3 over 2. Okay. So what is the ratio from DEF? What is the ratio of the perimeter from DEF to ABC? So what we would need to do is we need to put the perimeter of DEF and then put it over the perimeter of ABC. So if we add up the perimeter of DEF, we get 12 plus 15 plus 21. So the perimeter here is 48. And 8 plus 10 plus 14 is 32. So we need to, so I just wrote 32 up there for the perimeter. So DEF, so we need to do 48 over 32. So let's divide each one by 4. And we get 12 over 8, which then reduces to 3 over 2. And then that means that these are the same, so they are proportional. Okay, so similarity statements, the similarity symbol for it is this squiggle. It's like kind of like when we do the congruent, put that squiggle over the equal sign. Well, just if it's a squiggle, that means similar. A valid similarity statement must match corresponding angles and sides. To write a similarity statement for the above triangles, so we're going to write triangle ABC is similar to triangle DEF. Okay, and all of them match up. So like if we looked up here, A and D, B and E, C and F, it's the exact same thing when we were doing congruency statements. Okay, so down here at the bottom, we need to write the similarity statements for the angles. So angle J is similar to angle P. Well, angles are congruent, so we would actually write the congruency. Angle K is congruent to angle M, and angle L is congruent to angle N. Remember, it's the placement of each letter that has to match up. So if the first letter has to match with the first letter of the next triangle. So in the sides here, they're proportional to each other, and so if we take JK, JK is going to be the same thing as PM. KL is the same thing as MN. And JL is the same thing as PN. So all we're doing is writing whatever the sides that line up over each other, okay? So for this one, we have angle X is congruent to angle R, angle Y is congruent to angle Y, and angle Z is congruent, two Z's, is congruent to angle S, okay? Then we have XY, RY, YZ, YS, and XZ, RS. Okay, flip it over. So now we're doing it with not a triangle, but we're just doing it with a four-sided figure. It's going to be the same thing. All we're doing is just adding another side and another angle. So angle J is similar to angle Q. Angle K is congruent. I'm sorry, I shouldn't be saying similar. It should be congruent. We have JK over QR, KL over RS, LM over SP, and JM over QP. So all you're doing is matching up what letters match with what. Okay, so for the figure here, so if the figures below are similar, what is the scale factor? With the scale factor of 2 to 3, find the value of x. Okay, so we always read it as like 2, 2, 3. So it's saying 2 is this one and 3 is this one. So what we do is we write our scale factor and we set it equal to whatever we know about them. So we know this side is 42 and we're trying to find the side that is proportional to it. So what we do is cross multiply and solve. So 2x is equal to 126, x is equal to 63. So the value would be 63. So it's 6 to 5. Obviously the bigger one's going to have the bigger number too. So we have 6 over 5 is equal to x over 28. We get 5x is equal to 168 and x is equal to 33.6. So yes, there's going to be some decimals. I'm sorry. Okay. Now we don't have a scale factor, but we're still going to set up a proportion to what we know. So given this similarity statement, we need to find the value for x. So what we need to do is we need to set up what sides are similar to what sides. So AB is similar to DE. And BC is similar to EF. So then all we do is fill it in. X over 25 is equal to 28 over 20. What we need to remember is like one triangle has to be on the top of both. So we used AB over here, so that same triangle has to be the top of our other proportion. And we get 20x is equal to 700, x is equal to 35. Okay, the next one. So we have PS, and that is similar to WZ. And we have SR, and that is similar to ZY. So we have 75 over 40 and x over 32. So 40x is equal to 2,400, and we get x is equal to 60. So obviously we're going to add some algebra into this to do these problems, but we just set it up the exact same way. So we have AG over at KX and GM over XD. So we have AG is 32 over KX, which is x plus 3, and 36 over x plus 6. Okay, so we get 32 times x plus 6 is equal to 36 times x plus 3. Now we just need to distribute 32x plus 192, 36x plus 108. We get 4x is equal to 84, so x is equal to 21. So we have TL and CH and LY over x plus 5. So you get 25x plus 125 is equal to 40, x minus 10. You get 15x is equal to 135, x is equal to 9. Okay, so I hope this video helps, and that's it.